Science is an enterprise that relies upon the collaborative efforts of workers from around the world. Each study reported to the scientific community builds on the work of other studies completed before and communicates new findings to the next generation of scientists to broaden and deepen our understanding of how life works. The process of scientific communication is unlike the writing that you use in most other classes. Its purpose is to accurately, clearly, and succinctly communicate a research study to others so the work can be reproduced and verified as true and accurate. Good scientific writing is not measured by how many words that you use. It's measured by the completeness and clarity in expressing the thought behind a project, the methods that were used, the results that were obtained, and the meaning that was derived from the work. One format for scientific communication is the scientific poster. This is a less formal approach to conveying information than a podium talk or a journal publication, and it provides a more visible and lasting artifact. Scientific posters can also be used as a replacement for traditional lab reports, and in doing so, the student fulfills their obligation for reporting lab results in a format that also provides practice in this valuable writing technique. The parts of a scientific poster vary, but below is one approach that would work well. Title and credits. Name of the project, who did the work, where they are affiliated or where they did their work. Introduction. The background information that explains the importance of this project and why the work was done. Materials and methods. You must clearly and completely explain what you used and how you did your work so that others can read your poster, repeat your work, and get the same results. Results and discussion. In a poster, the results are often simply presented in data form. Tables, figures, photos, drawings, graphs, and legends for each that explain the what and how for each experiment depicted. The discussion is the researcher's analysis of the meaning of each piece of data and explanation of how the data contributes to find the answer to the problem at the heart of the study. Conclusions. Here the author generalizes the analysis and explanation to provide the take-home message for the project, and also to relate how this study has significance to previous work that was done on this problem. Literature cited. It is not expected that everything on a poster is original thought or work. Every study builds on knowledge contributed by others, and the citations would give credit to those previous studies that are quoted or have their meaning or methods or findings referred to or used in this poster. Acknowledgements. Often there are individuals who contributed to the work but who were not directly involved in doing the work going into this poster. Their contributions do not warrant being included in the list of authors in the title and credits, but they should be mentioned here. For more information, one individual for the research team will serve as the communications liaison for any incoming questions related to the study. This person, sometimes called the corresponding author, provides contact information here. Posters are traditionally several feet tall and several feet across. You may download a template at this location, or you can create your own using Microsoft PowerPoint and setting page dimensions to 30 inches by 40 inches. If resources for printing posters are not available on your campus, try saving the poster as a photo image for display on flat screen monitors or by digital projector. Here are some hints on poster creation and scientific writing. First, tense is important. There is a format in scientific literature that is very consistent, and it relies upon knowing what tense to use where. For instance, the introduction. Things that you might include in that would be, this is what we know is present. This is what has been done in the past, that's past tense. And this is what we intend to do, that would be future tense. For materials and methods, think about this. It is what we used and what we did. Those are both past tense. For results, this is what we found. That's past tense. Discussion. This is what the results mean. That is present tense. Conclusions. This is how it relates. Present tense. This is what we might do with it. That's future tense. For literature cited, know that it has a format all of its own. Use the style format desired by your instructor or that is specified by a journal. An example of instructions to authors can be found at the ASM, or American Society for Microbiology, website. For the acknowledgments, this is how they helped, so that's past tense. Getting the tense right demonstrates a clear understanding of scientific writing. 2. Style is important. Do not write as you speak. It is not a conversation. It's a more stylized professional presentation format. Do not, unless told otherwise by your instructor, use bulleted lists in a poster, but instead write out real sentences with nouns and verbs and capitalization and punctuation. Get your scientific names right. The easiest way to undermine a really nice poster is to be careless in the spelling and conventions used for scientific names. Capitalize a genus, but do not capitalize the species. Italicize both genus and species. And probably most important in this day and age, don't let spell check ruin your correct scientific spellings. Fonts are important. Use a font size sufficient to be read from a distance of 4 feet. Try 20 point or larger to begin with and see if that can be read from a distance of about 4 feet and yet still allows enough content to tell your story. Your narrative should use a different font from that's used for legends to tables and figures so that the reader can quickly tell what's part of the body of the writing and what is instead explaining the tables and figures. A suggestion is often that you use a serif font like a Times New Roman for the narrative and a sans serif font like Arial for the legends. Remember scale. Photos put into a poster are blown up significantly when the 30-inch by 40-inch poster is printed out. Be sure to review the poster at 100% size before printing to be sure all graphics maintain their clarity. Use color and contrast effectively. Light-colored text on a black background is very effective. However, it also eats up black toner, which adds expense to the poster. Be practical. Likewise, graphic-intensive backgrounds can play havoc with text when the contrast between portions of the photo or graphic and the color of the text is constantly changing. Think about using color fill-in text boxes as a way to distinguish texts from legends and titles and other sections. But always remember, the simpler, the better. Test it out before you print it out. A dark red font against a black fill in the title of a poster may sound like a really nice aesthetic touch, and it may look great on your computer. But if the lack of contrast results in the title being unreadable in the printed form, that wasn't a very good move. Make it easy for the reader to enjoy your work. All right, so let's use this information that you just learned to create a poster based on a VUMIE online project. You may work in research teams or individually as decided by your instructor. If you work in teams, your instructor will need to create an unknown and assign a case study for everyone in your group to share. If your instructor is not creating unknowns for you, please note that there is a poster exercise subgroup at the bottom of the subgroup list as you create your own unknown for this purpose. Remember that when creating a new unknown yourself, the microbe and the case study are randomly assigned by the software. Complete the identification of the organism. Remember that Section 2 of the VUMIE online activities includes guidance on strategies and test selection for doing this work. Use the content of the case study and your VUMIE online lab report as your starting point, as they provide important information about the scenario in which the microbe was encountered and the type of microbe responsible. Remember that the VUMIE online help system provides a library of references to provide some basic information of value to this work. Use these starting points for building the sections of the poster described below. They are listed in the suggested order in which they are added. That is, not the order in which you might expect, but instead the order in which the materials of value become available. First of all, the introduction. What's going on here? Use the case study for introducing the problem being addressed. Do some internet research and expand upon this as requested by your instructor. End the introduction with a statement about the goal being to identify the cause of the problem stated in the case study and how much information can be helpful in providing guidance for avoiding future problems of this nature. The materials and methods. This is the second thing that you will put in here. Begin your materials and methods with information from the case study about the source of the isolate, whether it's blood, cerebrospinal fluid, exudates, you name it. And then how the microbe was isolated and purified. I tell my students usually the way to start with this is that you isolated it, say from blood, and then it was purified by repeated streaking on agar media. We're doing streak plates to purify our cultures. Then you're going to state that it was gram stained. Don't describe the gram reaction, shape, or grouping of the organism here. That is a result, so it should be saved for that section. Your narrative in the materials and methods should continue with a statement like this. Identification of a pure culture of the bacterium was accomplished by using conventional biochemical tests. Continue it. Test methods used and interpretation were accomplished following the guidelines found in VUMIE online help files. Note, since this is going to be a reference to the software, you're going to have to include that reference in your literature cited section. Your own version of this will be tailored to the exercise and case study for your particular microbe. Results and discussion. Your results will be the figures and tables displaying outcomes of the work that you did in your ID. Figure 1 would be the gram stain of your bacterial isolate recovered from blank. You're going to fill in that blank. This provides not only the fact that this graphic that you have gotten from the software and put into your poster is the gram reaction and the gram stain that you did, that was done for you by the software. Not only that is what you did, but you also provide a legend to that. So it's figure 1, period, gram stain of bacterial isolate recovered from, and you fill in the blank with what your case study says. Then after that, you'll state the isolate is a gram positive, gram negative, whichever you have, coccus or bacillus, whichever you have, found as, and then you tell what the grouping is, singles, or it could be chains, or it could be packets of 4 and 8, or it could be grape-like clusters. So it's going to be one of those as you complete the legend for figure 1. Then the next thing that you'll have in your poster will be table 1. Preliminary tests performed in the identification of the bacterial isolate. Take a look at the ID strategy activity in section 2 that corresponds to the type of unknown organism that you have, either gram-negative bacillus or gram-positive coccus. In that strategy, in that particular activity in Section 2, it's going to list some recommended first tests to use in the ID process. You're going to be sure that you've done those tests, and you're going to list them in this particular table along with the results that you got for them. Table 2. List of remaining possible microbes following preliminary tests. Take a look at the ID matrix and list in Table 2 the names of all bacteria that remain a possibility for the ID of your unknown. The number should be 10 or so at this point after those first tests. Next you have Figure 2, dichotomous tree for completing the identification of the bacterial isolate. Use the ID matrix to select effective tests to efficiently and systematically test the unknown to determine its ID. Here you draw out a decision tree based on those tests to show how the results can lead to an ID. You can see examples of this that have been provided, and we'll get to those in a little bit. Table 3. Additional tests performed to identify the bacterial isolate. The list of tests used in your dichotomous tree is put into this table, and the results for each of those tests is presented. Then the discussion. The results show what the evidence is on the ID. The discussion explains what it means. For this, you will need to do some web research. We recommend that you use either scholar.google.com or the National Library of Medicine as your sources to cut out the non-scientific junk that's out there. This leaves you with more trustworthy information. First, search for information on your microbe. Finish the ID and you'll have the name of your microbe. Get to know a little bit about it, where it's usually found, what it usually does. Second, search for information on the case study scenario. Food poisoning, environmental pollution, whatever it is, take a look at that and see if you can find out what types of microbes are typically associated with problems of this nature. Search for information on your microbe associated with the symptoms or circumstances related to the case study incident. With these three searches, you should be able to find abstracts, and there's no need to pay for articles in this instance. You'll find abstracts that will help you build an explanation for the role of your microbe in this incident. The conclusions. This is the summary of the project. The identity of the microbe, how it relates to the case study, knowledge about the microbe confirms that this is a logical organism to find in these circumstances. External confirmation that this is a logical identification from the literature on this disease, right? A scenario for how the events of the case study were brought about by this microbe. And advice on how future incidents of this nature can be avoided. All of this would be nice inclusions, though not all are essential. The take-home message. This is a single sentence placed in a prominent part of the poster to help capture interest of the readers by stating the most important fact you want everyone to know about the project. Title and credits. Once everything else is done, now it's time to put a title on your project and also to list the members of your group, first name, middle initial, last name, your departmental affiliation, that is your department where your major is being delivered, and the college where the department is located, along with its city, state, zip code, and country. The literature cited. If you go beyond the case study to build your introduction, you need to cite the sources that you used here. Methods used in the virtual lab are presented in the software help files, so these files also need to be cited. If you use any outside information on the microbe, the case study, or in your analysis of the identification or its meaning or relation to the case study, it also needs to be cited. Any methods or processes from others, any ideas from others that you rely on to build your case, they need to be cited. And of course, you went to scholar.google.com and the National Library of Medicine and found articles that need to be cited here also. The acknowledgments. Your instructor will guide you in making decisions on how to approach this section. Thank them for their supervision and input toward completion of the project. For more information, one individual from the research team will serve as the communications liaison for any incoming questions related to the study. This person, called the corresponding author, provides contact information here, usually an email address. To see how this might look, I've provided a couple of sample posters created using VUMIE Online in a real microbiology class. Check them here. Want more examples? Need some pointers? Here are some resources that may help. This one provides templates free of charge. For a video tutorial on the process, look here. The content and style may vary slightly among these resources, but the end result is always the same: effective presentation of scientific information. With these resources, the process of creating outstanding posters for this class and others should be easy. You can actually print an 8.5 by 11-inch version that is legible to allow you to preview the product before its submission. Be a good writer.